This is the fourth part of my series on OpenTX programming for helicopters. This will be the final part of the series unless there's a need for follow-up additions, response to questions, comments, etc. This part deals with programming for helicopters requiring CCMP mixing, cyclic collective mixing, in the transmitter, i.e. helicopters where, rather than having an onboard flight controller, there is simply an onboard receiver with one channel of that receiver connected directly to each of the cyclic servos. This is typical of larger and older helicopters. It is much less common with helicopters that have come out at all recently. It would help if you have reviewed the previous videos in this series, as there's a lot to cover in this video, and I will not spend a long time defining terms and going over things that I have covered in the previous videos in the series, which are not particular to this type of heli being addressed here. Anyway, let's get to the programming, which is going to be done as in the other videos in OpenTX Companion. So, I'm programming here for an older 450 size helicopter with a FlySky receiver in it, and I'm programming for my jumper T16 because that's the OpenTX transmitter I'm using at the moment. I've got a timer conditional on a logical switch, and the logical switch is conditional on the throttle channel being over -80. This is the same as in the other helicopters that I was dealing with. I've got my throttle cut on switch F, so I've got the alert position on my switch F reversed because I like to have my throttle cut flicking off with the switch away from the back of the transmitter. And I've got the multi-protocol module inside my T16 set to use FlySky protocol. Now, I've also got 3 flight modes declared, much the same as the other helicopters that I covered earlier in this series. 4 flight modes with a hold mode as the default mode, and then normal, idle up 1 and idle up 2, each dependent on logical switches 1, 2 and 3, and logical switches 1, 2 and 3 are dependent on SF being back, i.e. throttle hold being off, and switch E, which I'm using as my idle up, my flight mode switch, being in the back position for normal mode, the middle position for idle up 1, and the forward position for idle up 3. All this is exactly the same as the other helicopters I dealt with in this series. What is different is that, of course, in these helicopters we use the Heli page, because that is what the Heli page in OpenTX is for. You must, of course, have the Heli page in order to do this, and if you set the No Heli option in OpenTX Companion when you download your firmware, you won't have this page. So you must make sure that when you're getting your firmware, you don't have the No Heli option set for this type of helicopter. Otherwise, you simply just won't have this page. If you can't see this page, if you go straight from setup to flight modes, then you've taken a version of firmware with a No Heli module set, and you'll have to re-download the firmware and reflash your transmitter firmware. Okay, so what we set on this Heli page is the swash type. By far the most common swash type is 120. Sometimes 120X is required. Actually, I have a feeling this helicopter actually did require 120X. I'll see in a minute when I look at other versions of this model, because I'm going to show you a couple of different versions of this model. Actually, let me just look at the second version a moment. No, I've still got that set as 120, so maybe 120 did work. The basic difference between 120 and 120X is the servos are at 120 degrees, i.e. evenly spaced around the swash. It's just 120X basically flips the front 2 servos. The swash ring setting is a number basically between 0 and 100, which basically controls the movement, the degree of movement of the swash. And you basically probably want to adjust it by looking at your swash and see. I don't know how else you'd adjust it, and seeing that you're getting a reasonable amount of movement. That you're getting, if you're getting too much, reduce it. If you're getting too little, increase it. somewhere around 50 is a good place to start, probably. You're then going to define 3 inputs to your cyclic collective mixing. 2 cyclic inputs and a collective input, which is why this is called cyclic collective mixing, because you're mixing inputs for the cyclic and the collective. You have a longitudinal cyclic, that is the input which is going to tilt the helicopter forwards and backwards, a lateral cyclic, which is going to tilt the helicopter from side to side, and a collective, which is going to increase or decrease the pitch of the blades. So I've got these 3. I've got the lateral cyclic defined to be input 1, the aileron input, which makes sense if you think about it. The longitudinal cyclic defined to be input 2, the elevator input, which normally tilts a vehicle up and down, pitches the nose up and down, and 6 defined to be the collective input, which is a second input that I define dependent upon the throttle stick. So if we go and look at the inputs, I've got aileron, elevator, throttle. Throttle is dependent on the throttle switch, varying according to 4 throttle curves. Again, this is just like the earlier helicopters that I dealt with in this series, so I don't want to spend vast amounts of time going over this, but we've got a flight mode. We've got our flight modes dependent upon the hold switch and the flight mode switch. If we're in flight mode 1, throttle is varied according to the flight mode 0 is hold, so the throttle is varied according to the hold curve. If we're in flight mode 1, which is normal mode, throttle is varied according to the throttle normal curve. If we're in flight mode 2, which is idle up 1, throttle is varied according to the idle up 1 curve. If we're in flight mode 2, throttle is varied according to the idle up 2 curve. These curves are defined on the curves page. So there's your throttle normal curve. This is throttle going up for normal mode. Your hold code is just a straight minus 100. If you're in hold mode, the throttle is not allowed to move from minus 100. In normal mode, it moves up fairly quickly and then more evenly once it's got to a certain point. And in idle up, it goes in a little V. Or some people prefer it flat, but I've got it in little V's, but a higher little V for idle up too. Collective is an additional input which is defined to control pitch, and is also conditional on the throttle stick. So these 2 inputs are both driven by the throttle stick. When we define their source here, defining them, we define the source to be the throttle for both of them. So we've got 2 inputs because it's very logical with a helicopter. The throttle stick drives the throttle and the pitch. For the pitch, we use a pitch normal curve in normal mode, and I've also got the pitch normal curve set to operate in hold mode. You don't really need that. It just helps that you can see that the pitch is changing, with it when you're still in hold mode. I've got the pitch set to vary according to my pitch idle up 1, PI1. I'm using these short names because you only get 3 characters for the name. So PI1 is my pitch curve for idle up 1, and that applies when I'm in flight mode 2. So, the way we're actually setting this, so we say it's dependent on the throttle, it's dependent on a curve. We choose the curve, which in this case is idle up 1. We choose what flight mode it's applicable in, and that's what causes this to get set. And I see for some reason I don't have the no trim option set on that one, so I should really have the no trim option set there, because I don't want to be trimming the trims to be affecting the pitch and the throttle. I've got my rudder on input 4, which will be the left stick side to side. I've got my gyro being set via switch B, so it'll be 80% when switch B is back, 70% when switch B is in the middle, and minus 75% when switch B is down. This is assuming that this is for the rudder gyro. These kind of helicopters, the only gyro these type of helicopters have is a gyro to control the turn of the rudder, and it typically has heading positive gyro values typically produce heading hold gyro, and negative values produce rate gyro. So basically I'm saying switch B back I've got 80% heading hold gyro, switch B in the middle I've got 70% heading hold gyro, switch B towards me, I've got 75% rate gyro. It's not a bad idea if you're flying this type of helicopter to have a setting where you can switch to rate gyro, because sometimes it can get you out of problems to switch from heading hold gyro to rate gyro. Okay. I have current. Well, yes, this is fairly important. This is the mixes page. Now, in the mixes page, this is very different for this type of gyro, this type of helicopter. I'm sorry, because the whole point is this heli page creates. If you define the swash type as anything other than 90, it creates 3 inputs, 3 values called cyclic 1, cyclic 1, cyc 2, and cyc 3. If you choose the 90-degree setup, it only creates 2 throttle input, 2 cyclic inputs, cyc 1 and cyc 2. These cyclic inputs, this cyc 1, I'm saying the source of this is cyc 1. Cyc 1 won't exist unless you define stuff on the heli page, because cyc 1 comes from the heli page. Cyc 1 is the output from the heli page, which is intended to drive the first cyclic servo. And then this second line is dependent on cyc 2, so this is the output from the heli page designed to drive the second cyclic servo. And down on channel 6 I've got cyclic 3, which is the output designed to drive the third cyclic servo. This is assuming, because these are going on channels 1, 2 and 6, this is assuming that my actual cyclic servos on the receiver on the helicopter, and which they are on this particular helicopter that I'm programming for, are connected to channels 1, 2 and 6. The throttle is connected to channel 3, the rudder is connected to channel 4, and channel 5 is connected to the gyro, which basically means that it has a wire coming out of it. It's usually only a single wire as well, in this case, that connects to the rudder gyro. The rudder gyro is a little box on the back, on the tail boom, and you'll see typically it has 2 connections coming to it, one of which is the rudder, which actually conveys the rudder command, swing left, swing right, and the other is a gyro setting to set the gyro, and that's where our gyro value here is being sent across to the tail, to the gyro, the tail gyro. And then we're just putting all these outputs out. I've got 2 of them reversed because that's necessary for this helicopter. You're gonna have to figure out for yourself which ones need to be reversed. I mean, it's easy enough for the cyclics, because you can check, you can bind the helicopter and see how they're moving. If you move the stick right, the swash should tilt to the right. If you move it to the right and it tilts to the left, then you need to reverse your aileron, your channel, your lateral cyclic channel. Likewise, if you push the right stick forward and the swash tilts back, then you've got to reverse your elevator, your longitudinal cyclic, channel 2. In this case, I found I needed to reverse channel 1, did not need to reverse channel 2, and I need to reverse channel 4. Channel 4 is the rudder. Actually, because these kind of helicopters typically have a pitch-operated tail, it's a belt-driven tail with a pitch, you can actually see the pitch of the tail varying as you vary the rudder. So you can actually tell whether the rudder is in the right direction, so long as you figure out what the pitch is doing. When you push the rudder stick to the right, that should turn the nose of the helicopter to the right, so it sort of adjusts the pitch of the tail rotor to push the tail to the left. Right, rudder right, tail left, should be. Likewise, and of course, rudder right, tail, rudder left, tail right, so that it points the nose in the direction you want. Don't have any other logical switches. Now, where I have a problem here, and I do have a problem, I have a problem with OpenTX here. Well, let's just cover the special functions before I get to my problems. The special functions are pretty straightforward. I've got an extra function to say that when switch F is back, channel 3 is overridden to -100, and that switch is switched on. And never forget to switch your special functions on. If you want to have a special function do anything, and this little on box comes up, be sure to always tick the on box, because otherwise the line won't do anything. Switch H resets timer 1, just so I can reset timer 1. Switch F plays a throttle held or throttle active sound to tell me I'm holding or not holding my throttle, which I really like to have. I really like to be told I've got my throttle hold. Now, this is redundant, strictly speaking, because once you're in hold mode, because of the way I've defined hold mode, the pitch curve for hold mode is always at 0 anyway, so I shouldn't really need a function to override channel 3, but anyway, I like to put one in. It never hurts, although it's like technically it's actually redundant. And logical switches 1, 2, and 3 drive the 3 flight modes: normal mode, idle up, and idle 2, so they play the sounds that say normal up, idle 1, and idle 2. Now we come to where I have a problem with OpenTX. See, I'm defining the inputs to my lateral and longitudinal cyclic as input 2 LE and input 1 aileron. Right. And I've got them currently set to 100. This is basically a weight that is applied to the input in the Heli page. So you can put a weight in there, but what you can't do is you can't vary this according to a switch. You only get to put in a single weight there. So if you want variable rates, how do you do it? Well, I would have thought the logical way to do it, since I'm defining the input to the longitudinal and lateral cyclic as my first two inputs, I would have thought the way to put variable rates on them would be to vary those inputs. So that's what I'm doing here. I'm using switch G, my intended rate switch, to vary the input 1 to 70, 85, or 100%, all with 30% expo, and the input 2 to 70, 85, and 100%, all with 30% expo. Now, I would have thought it would be logical, given that I am using those two inputs as the input to the lateral cyclic, that if I change them, that should change the cyclic and should result in a change to the cyclic output, which is these things, SIC 1, SIC 2, and SIC 3. So if I would have thought, if I tilt my cyclic sideways, if I'm halving the weight by which I tilt it sideways, then that should halve the output, and it should actually tilt half. Unfortunately, in OpenTX, that doesn't seem to work. This should work, I think, but it doesn't. I can show you what I mean. It doesn't work in the simulator here. The relative channels, right, are cyclic 1, cyclic 2, and cyclic 3 are on channels 1, 2, and 6. So now they're just sitting in the middle at 50, minus 50, and minus 50. The reason they would be sitting level, except I've got one of them reversed, which causes them to be different. Let's go just for a moment. Okay. Let's put the helicopter in idle up mode. We are now in idle up 2 mode because we've got switch E down and switch F down, and we'll go into low rates, and we'll put the throttle, if I can, it's hard to do precisely, there, in the middle. In the middle. So now I'm basically at 0, should be at 0 pitch, essentially. And switch G should not make any difference to the pitch. We don't want switch G to make any difference to the pitch. It's supposed to be affecting the rate of the lateral cyclic. So if I pull, well, and the longitudinal cyclic. So if I pull down to the bottom corner, I should be applying maximum back cyclic and maximum left cyclic. And if you look at channels 1, 2, and 6, you'll see the values have got a minus 47, minus 20, and 29. That's supposedly in low rates. So that should be only applying 70%. Now if I go and apply 100%, what do I get? Minus 47, minus 20, and 29, i.e. exactly the same values. And this is just not some aberration of companion. This really, I've checked it on the helicopter as well. It really happens on the helicopter, i.e. putting in rates this way achieves nothing. OpenTX just ignores it. You say here that the input to the longitudinal cyclic is input 1, and you say here the input is input 2 to the longitudinal cyclic, input 1 to the lateral cyclic. But in actual practice, it seems to me what OpenTX is really doing is just taking the raw stick value, the raw aileron and elevator stick values. It's totally ignoring any parameters you define here. Anything you define here, all this stuff, anything you define here, it's just ignored completely by OpenTX. when you're using it to program a helicopter like this. It says it's input to Heli, but it's not really taking the actual parameterized value here of input to Heli. It's just taking that. It's just taking the source of that, the raw elevator stick. So there's absolutely, you can't put mixes in like this. It just does not work. Absolutely doesn't. So there's no point doing it. So you might as well not do it. You might as well just do that, because it's not anything you put in here is going to be completely ignored by OpenTX. Now you can vary the rate by changing this. I could get a 70% lateral. I could get 70% lateral and longitudinal rate like that by changing the rate there. But I actually have to come into the programming to do that. I can't make that happen on a switch, because this is not switchable. It's a fixed value. Once you save it, it's saved, and that's what happens. And it drives, you know. So the only way you can change it is to go into the programming and change the programming. I wanted to change my lateral, longitudinal, cyclic rate via a switch. But you can't do it by putting parameters in here, because the Heli page, in calculating the cyclic values, ignores it. You can do it for the rudder. The switch will control the rudder. So I'm switching between 90, 95 and 100% with no expo on the rudder, and that works. If we look at the rudder channel's channel 4, so if I pull the rudder right over, it goes to 90 in low rates. In mid rates it goes to 95, and in high rates it goes to 100. So the weights work fine here for the rudder, but they do absolutely nothing if you put them in there for the lateral and longitudinal cyclic. So this is another version with a different way of putting in mixes. Now what I'm doing here is putting mixes on the cyclics themselves in the mix page. Yeah, this is not an ideal solution, but it's another way of doing it. The problem with this is this works. This will vary the rates. Now, so if I go to low rate, when I pull right over, I've got -4, -33, -5. If I go to mid rate, I've got -5, -40, -6, and if I go to high rate, I've got -6, -47, -7. Not a big difference, but it does vary. So that does cause a variation in the rates. The problem is, as you may well have spotted if you're thinking this through, that these cyclics here are not only defining the tilt of the swash plate, they're also defining the pitch as they go up and down. That's the whole point. They're coming out of the Heli page and they've been mixed. They've had the cyclic and the collective mixed in already. So if we apply rates here, we're applying a rate not only to the tilt but also to the pitch. So if we apply 70%, we put the switch in the back position, and we get 70%, we'll get 70% less forward tilt and back tilt with the right stick, and 70% less right and left tilt, but we'll also get 70% left pitch, which we don't really want, but this seems to be the only way of putting switchable rates in OpenTX that I can see. So you can do it one way, you can do it the other way. If you do it this way, you really need to beware of a couple of things. Well, for one thing, you must put the rates into all three cyclics identically here. If you start putting different rates into cyclic 1, cyclic 2, and cyclic 3, you're going to cause all sorts of problems, because as you switch from one rate to another, the three servos won't move together. When they move up and down in pitch, they must move all move exactly the same amount, just change the pitch but not change the tilt. If when you vary the pitch, one of them moves at a different speed to the others, you'll get tilt when you vary the pitch, which you don't want. You'd probably crash your helicopter for sure if that happened, if every time the pitch varied, the helicopter also tilted backwards or flew off to one side or whatever. So in order to avoid pitch changes causing tilt, if you're going to put anything in here, any rates in here, you must put it in identically, both in respect of weight and expo for all three cyclics. So you'll see here I've got the same values in here. I've got 70, 85 and 100, 70, 85, 100, 70, 85, 100, and all with 30 expo. You can vary the expo between one and another, but it must, if I make the top one expo 40, I must make it expo 40 on all three cyclics. The definition of the three cyclics here, if you're going to put anything in, must be identical, because if you don't put it in identically, the swash plate will not move correctly, because these are going directly to the servos, so you're going to start skewing the response of your servos if you change them, if you make them different the way they're mixed. The other thing is that if you're going to define it like this, I would definitely not suggest that you take off in high rates and then switch to low rates, because you're going to reduce your pitch when you switch to low rates, and you might end up with less pitch than you need to keep the helicopter in the air. So it's not a good idea. If you're going to do it like this, you probably should only switch rates when you're on the ground, quite honestly. If you find the rates are too high, land the helicopter, switch to the low rate, so it doesn't gain you all that much over programming it, really. Because you'll find you can switch rates in the air with it like this, but you will find that when you switch rates up, when you switch to a higher rate, not only will the tilt increase, the pitch will increase, so the helicopter will tend to jump up as you switch to a higher rate because you're increasing the pitch. Likewise, when you switch to a lower rate, the helicopter will tend to drop because you're lowering the pitch, which we don't want. I mean, I don't want that. I just want to vary the tilt. I don't want to vary the pitch based on a rate switch, but I don't see a way to do it in OpenTX, because if I put it in here, which is where it seems to me I should put it in on the inputs, the rate on the inputs, so it goes into the lateral cyclic but doesn't affect the collective, then unfortunately it seems like OpenTX just ignores it. So your choice, you can do it one way or the other. You can either just, if you want to have rates that work for tilt, you're going to have to, I think, put them in here. Or you can just not put rates in and just be content to only have rates, switchable rate on the rudder, in which case if you want to vary the rate of your cyclic, you're going to have to land and change the actual programming by changing the rate in here. I'm sorry if this video's got rather complicated because of this convoluted, explanation of problems I'm having with OpenTX, and if someone who knows OpenTX better than me can refute what I'm saying and explain how I can get rates on my switchable rates on my lateral and longitudinal cyclic without interfering with a pitch, please do tell me, and I'll make a follow-up video to clarify that. But this is the state of where I'm at in terms of trying to program CCMP mixed helicopters in OpenTX at the moment. And although I've been jumping backwards and forth, I believe I have covered everything that's defined here. This is where my outputs get named. Names are only important for clarity. This is where they get reversed. We've discussed my mixes. This version doesn't have any mixes, except you've got to be very careful. Of course, you've got to take the cyclic inputs. If you define stuff on the Heli page and then don't use these cyclic 1, cyclic 2 and cyclic 3 inputs for anything, then anything you do on the Heli page does nothing. All the Heli page does is create these cyclic 2, cyclic 1, cyclic 2 and cyclic 3 values, which can then be used and put out to a channel via the mixes page. And of course you obviously have to make sure, testing with the helicopter, that it's actually moving the swash correctly. As I say, I'm sorry if this has got a bit garbled because of the problems I'm having getting mixes to work in OpenTX. I hope I've explained everything that needs to be covered to basically, and all of these 3 versions I've shown will fly the helicopter. You just need to be a bit cautious about the rates, as I say, in the version that has the rates on the it's not the version. I'm getting confused now. Where are we? This version, I guess. Yes. This version that has the rates. This version that has rates on the cyclics. You have to be very sure you make them the same, and you probably should not switch them in mid-air, at least not until you've made sure you can fly safely with all 3 rates. I hope I've covered what you need to know to program this type of helicopter in OpenTX. If you have any questions, please do feel free to ask in the comments, and if you can explain a way around the rate issue that I haven't managed to reach, please do put that in the comments as well, and I will post a follow-up video clarifying that if I find a better way around it. As it is at the moment, as I say, you can fly it. You can fly it in either of these ways, and they will. These programs that I'm showing you here will all fly the helicopter that I've defined them for. But you have to be a little bit careful with this varying the rate issue, because if you put the rates on the cyclics into the mix page here, it will change the pitch as well. So when you go down to 70%, you won't only get 70% of the tilt, you'll get 70% less pitch. Well, no, 70% of the pitch, 30% less pitch, which may make quite a critical difference depending on the particular helicopter you're flying. Okay, please post in the comments if you have questions or additions, and I will respond in the comments, or if applicable, make up a follow-up video to clarify.